You know, getting to the outer solar system is one of humanity's absolute biggest challenges. Today, we're diving into a pretty wild but surprisingly plausible solution. What if we could turn one of Saturn's moons into a deep space gas station?
Right, this is the big one. This is the fundamental problem that pretty much keeps us tethered to our little corner of the cosmos. I mean, if you want to go far, you need a ton of fuel. But where do you get it once you've left Earth behind? You see, the biggest hurdle for exploring planets like Jupiter or Neptune isn't just the mind-boggling distance. The real problem is fuel. You have to pack every single drop you're ever going to need right from the very beginning of your journey. And that brings us to this brutal law of physics, the tyranny of the rocket equation. It basically says that to go faster or further, you need more fuel. But that fuel is heavy, which means you need even more fuel just to lift the first batch of fuel off the ground. It's this vicious cycle that really limits how far we can go. And this comparison just lays it all out, doesn't it? On the left, that's us right now. Huge, inefficient rockets on what are essentially one-way trips. But on the right, that's a future where we can top up the tank in deep space. That simple change, that one ability, could literally turn the entire solar system into our backyard. So, what if there was a natural gas station just waiting for us out there, perfectly positioned in the outer solar system? It really does sound like science fiction, but you'll see the science here is surprisingly solid. Okay, meet Titan. It's a truly bizarre world. It's so incredibly cold that its rivers and its lakes, they're not filled with water. They're filled with liquid natural gas. And it just so happens to be the almost perfect candidate to solve our deep space fuel problem. So here's the crucial point. Titan has everything we need to create modern rocket propellant, and it's just sitting right there on its surface, or just underneath it. You've got liquid methane for the fuel, you've got water ice that you can crack open for oxygen, and you even have a thick atmosphere to help you slow down when you're coming in for a landing. It's the whole package. And the chemistry is just beautifully simple. You take the liquid methane from Titan's lakes, combine it with oxygen that you've pulled from all that water ice, and what do you get? Methalox, the exact same propellant used by some of our most advanced rockets, like SpaceX's Starship. It's like finding a fully stocked, ready-to-go fuel depot in the middle of an unexplored ocean. But, getting the fuel is really only half the battle. Landing a massive rocket on an icy, maybe even unstable surface, well, that presents a whole new set of challenges. I mean, really think about that for a second. A rocket like Starship lands with incredibly powerful engines blasting superheated gas. On Titan's icy surface, that's not a landing, it's a drill. You could just melt your own landing pad and sink right in. So this isn't a simple touchdown, it's a really complex engineering puzzle. Well, the proposed solution is like this carefully choreographed dance. First, the ship actually deploys its own solid landing pad. Then, it uses smaller thrusters mounted up high, angled away from the ice, to come down safely. Once it's stable, it can literally just siphon methane from a lake, while another system goes off to mine water ice and zap it with electricity to create all the oxygen it needs. It's a completely self-contained landing and refueling system. So once you have a reliable way to land and refuel, the next logical step isn't just to visit Titan, is it? It's to stay. And the very same resources that power the rockets could also power a human presence. And this is where the whole concept just levels up. Titan stops being just a gas station. It becomes a genuine off-world colony. By living off the land, a base there could become a permanent, self-sustaining hub for exploring the entire outer solar system. There's this one incredibly clever idea for the habitat itself. So you'd burn methane for power, right, which produces CO2 as exhaust. But instead of just venting that CO2, you'd pipe it into a transparent outer layer of your habitat dome. That CO2 would act as a super efficient greenhouse gas, trapping heat and insulating the living space. On Titan, even your waste product becomes a critical building material. And hey, if living on the surface isn't futuristic enough for you, Titan's crazy atmosphere offers another wild possibility. It's so thick and dense near the surface that you could potentially build entire cities inside giant balloons, just floating in the upper layers like these majestic airships. I mean, it is a concept straight out of science fiction, made possible by the unique physics of another world. So let's bring this all together. What does all of this incredible engineering and resourcefulness actually get us? What's the grand prize here? This is the ultimate payoff.
Titan stops being the final stop on the tour. Instead, it becomes the starting point. It's the forward operating base, it's the shipyard, and it's the fueling station that gives humanity a permanent foothold deep in the cosmos. A setup like this changes everything. What was once a one-way trip, a shot in the dark, now becomes a multi-stop journey. A much lighter ship leaves Earth, makes a pit stop at Titan to refuel, and then has the freedom to travel to any other world in the outer solar system. And maybe, just maybe, even come back. So ultimately, the question we're left with is this. Could transforming this cold, distant, methane-soaked moon into a bustling outpost be the single most important step in humanity's journey to becoming a truly interplanetary species? It is a bold, bold vision, but it's one that could completely redefine our place in the universe.